Hey everyone, welcome to day 4 of Code Week. Today we'll be going over ASCII image art, and this is the advanced version of the workshop. So to introduce you guys to this topic, I've pulled out the Google search and to show you what ASCII image art looks like. So basically, all ASCII image art is it's converting a traditional image into this sort of very special looking image or art. So you, for example, this is like the GitHub icon, but essentially these are all characters. Each pixel you see are characters. And so just using a set of ASCII characters, we can convert super complex images into characters that we can understand. So this is a person. This is we recognize it's a person. This is like a sort of ant. So you can really make some very cool art. And just to give you a little bit of history, ASCII art actually has its origins in typewriter art, and it was created in the late 1800s. And in the late 1960s, when computers had minimal graphics processing hardware, ASCII was used to represent images. And even today, ASCII art, it really continues as a form of expression on the internet, and you can really find a variety of different ASCII arts online. So this is what I'm showing you right now. And so today what we're going to be doing is going over how to use Python to convert an image into ASCII art. So that's going to be very exciting. And so the fundamental principle, the key idea today is about taking advantage of the fact that from a distance, our eyes perceive grayscale images as the average value of their brightnesses. So let me just pull out an image, for example, of a building, okay? And so we recognize this building because, we recognize this building, but we can transform this into a sort of ASCII image art by converting each of these pixels into some sort of grayscale, into a grayscale. And then we can use different characters to represent different densities of this grayscale. So in other words, something like a period, a small period, it's not very dense, whereas something like this symbol is way denser. So something that's super dark, we could represent by this, whereas something that's super light or white, we can represent that by a period character. And so let's get straight into coding, and let's see how we can implement this. So I'm gonna minimize this and I'll pull up PyCharm. And so we're gonna start with the tutorial. I'm just gonna zoom in and we'll start coding. So to do this, first we're going to need to use a library called Pillow. And so from Pillow, we're going to import image. And I also want to import argparse. That is going to allow us to write out commands from the terminal, which we're going to do later on. So the first thing we need to define, as I said before, is our grayscale. And I'm going to copy paste my grayscale that I have. So this is the line of code. So as you can see, at first it's super dense. So these would represent super dark values, super dark pixels. And as you go forward, you notice that, it's less and less dense. So this right here represents a character, something that's like extremely white, whereas this represents something that's super dark. All right, so we've defined our grayscale. And now we need to write a function. And this function is going to convert the image, right? So the idea behind our algorithm is we're going to take an image and we're going to convert it into ASCII art, right? So our input first, we need some sort of file. So we'll just call that file image name. And then we want to have two other parameters as our input for our function. The second being scale and the third being output file. So scale basically is how big do you want to scale the ASCII art, right? Because the original scale would be, this is 665 by 900. So if we want to preserve the original scale, it means that our ASCII art would be 665 characters by 900 characters, each character representing a pixel on this, right? And since this is 665 pixels by 900 pixels, and we'll have that. But sometimes we'll see it doesn't look too great when we have a super big scale, and sometimes we just kind of want to scale it down a little bit. And so that's why we have that parameter. And then we have output file. So this is the name of the file that we want to store our ASCII image art in. So that's why we have those three parameters. And so we'll write this image file equal image.open image name. And while you guys are following this tutorial, make sure you're coding along and understanding why I'm writing each line. So what we're doing over here is just opening this image. So this is the name of the path name. So let's say our image is called like image.png. So it'll be here, and we open it using this image library, and we store it in this variable. And we're doing that because in the next line, we want to rescale it, right? As I said before, we can use something called Imagefile.resize, and we're gonna pass in the new size, Imagefile.size 0 times scale, and int Imagefile.size 1 scale. All right, so what we're doing here is rescaling our image. If we don't want to worry about it, like the default, we keep it to 1. And basically, Imagefile.size gives us the dimensions of our image. So, for example, if we passed in this image, it would be 665 by 900. So at the 0 index, it would be 665, and at the 1 index, it would be 900. But if we keep the default scale, then it's just gonna maintain the same size. All right, and then we want to take care of also the output file, right? So we can say, I don't know what to call this. Like I wrote FO, so FO is equal to open output file, and we want to write into it. And now this is where I'm gonna have another function. I'm gonna call this transform data. Just trans data is equal to transform ASCII image file. Okay, and of course this is in red right now because we haven't defined our transform ASCII function. So I'm gonna write it over here, and it's gonna take in a parameter called image file. So I want to write a function that's gonna transform the image file now that it's kind of processed, and I want to return a string of characters that's gonna represent the ASCII image art. And then after that, I want to write something over here that's gonna store the ASCII image art into a text file, and then that would be the end of the function. But I just wanted to separate it so it's a bit clearer. So here it's passed in an image file. This is an image path. So maybe we could call it image path. So it's less confusing for you guys. Whereas this is the actual, based on the path, we use the image library to open it and store in a variable called image file. And so we're transforming this image now, and this is where it's really the core idea of our algorithm. So the first thing we want to do is convert our image into grayscale, because if it's just in RGB color, it's going to be a bit difficult to it's going to be impossible to convert it and translate it somehow into our characters. So first, let's just convert our image to grayscale. So let's say image file equals image file, and there's a very nice built-in function called .convert, and we're gonna say .convert to L. And then we would just want to store the width and the height of this image file. And again, we're going to use imagefile.size 0, imagefile.size 1. And so now we have the width and the height, okay, of this image file. And so what we want to do is go over each pixel of this image file. Okay, so we're going to go over let me pull out this. We want to go over each pixel. So again, referring to this image, this is 665 by 900 pixels. So if we preserve the original image, I'm going to go over each pixel. Okay, so each pixel on the vertical aspect and each pixel horizontally and vertically. Okay, go over each of these pixels, and we want to because we've converted into grayscale, we can use a cool function that just gives us a value on how dark or how light this pixel is. And then we'll use our grayscale values that we've defined before over here to determine which ASCII character to use. Okay, so it'll make sense a bit more as we code this. So before that, I guess I just want to print it out. Print image dimensions are, and then we'll just do width by height. Okay, so image dimensions, and then it's gonna print out the width by the height. So yeah, the first index would be the width, and the second index would be the height. But then we'll store all of this inside of a string, and we'll initialize it with an empty string. Okay, so we're gonna go over, as I said before, for h in range 0 height, we're gonna go over each pixel. So this is what I'm doing over here for w in range 0 width. So what this does is, let's say the height is 100, then it's going to do for h in range 0, 100 for w in range 0 width, and width, if it's 100, then be for h in range 0, 100 for w in range 0, 100. And then what we're going to do is get the grayness, right? So pixel grayness is equal to imagefile.getPixel width and height. Okay, so we have the coordinates because we're looping over that, and so this get pixel at the width and the height, it gets the pixel at that width and the height, and it returns the grayness of that pixel. So if let's say this picture over here, you know, at first it starts over here, and then it runs the width first. So it's gonna go like this, it's gonna go like this, and then it's gonna go down, and it's gonna go like this, like it's gonna scan horizontally until it reaches the bottom. And so for each pixel, we're gonna get the grayness, and then we're gonna append to our string, our code pick string, right? Code pick plus equal grayscale int pixel grayness over 256. So I'll just write it, and then I'll explain what we're doing. Over times length minus 1. Yeah, I think this is good. And this should be plus equal. Alright, so this looks a bit confusing, but essentially pixel grayness is going to be a value between 0 and 256. So the grayer it is, the higher, like the darker it is, the higher value it is. Or the low, yeah, the higher value it is. And so we want to translate that into some sort of grayscale. So we're, this is the grayscale. We're gonna index over it. So we're gonna index over a string. We wanna determine which of these to use, right? So depending on how gray it is, we're gonna want to choose different values. Okay. So if the greenness is 0, then we're gonna get the first element. If it's 256, then we're gonna get the last element. And if it's something in between, then we'll get something in between. So this is what we're doing here, and there's a -1 here because if the value if this divided by that, if pixel grayness divided by 256 is 1, and we don't have this -1 here, we're gonna get something out of the index of out of the string, right? So it's gonna be out of bounds if we don't do this -1. And there's an int here because we want to make sure it's an integer, not some floating value. And once, so we do this for an entire row of pixels. Okay, so we do that. So let's try to visualize this. We'll do that for the first row of pixels, and then so then it'll become, this code pick would be something like, something like this. So, and that represents the first row of pixels of the image. But then we want to change to a new line, right? And because ultimately the image art looks something like this, right? So how do we do a new line? Well, it's very simple. After we're done with a row of pixels, we'll just append, or just add, we can't append to a string, so it's plus equals, and we're gonna plus equal a new line. Code pick plus equal new line. Oh, sorry guys. Okay. And then we're gonna repeat this process until we're done with everything. And finally, we're just gonna return this string. And that's the algorithm. It's not too complicated. Recap, what we did is we converted into grayscale. We got the dimensions of the image, and we iterated over it. So we can go over each pixel coordinate. We get its pixel greenness at each of those coordinates, and then we just simply replace that value with this grayscale based on what we define for a grayscale. Like what ASCII image art, what ASCII character to use based on the greenness, and we appended it to this code pick, and we add a new line every time we're done with a row of pixels. Okay. And so let's go back to our function. So now trans data is going to be the transform. It's going to be the ASCII image art. So we can just print that out just to see what it looks like. And then we also want to just write it to our text file, right? So that's what we're going to do here, and then we're going to close it at the end. So we're done. Those are the two functions. But I want to just have something a bit cooler, that's more interactive. So I'm going to define main. And I think it's going to take a bit of time to write it down. So I'll copy paste it. And I'll also link this code afterwards. But I'll just quickly explain what we're doing. So this is using an argument parser. So that way we can just, we can write Python tutorial.py, and it will be I'll be able to define these parameters. So the first parameter is the file, which is going to be the file name, and then we'll have the scale and the name of the output file. Okay, and so the first one is required, the scaler is not required, and the output file are not required. So these ones are going to have a default. So the default for the output file is results.txt, and the default for the scale is 0.43. And what we're going to do is we're going to pass in these arguments when we run this, and it's going to run this function. ASCII image is equal to convert image file. So we call this function convert image, and so that's going to convert the image based on these three parameters, and then it's going to print after it's done, it's going to print ASCII image already written to the output file. And this actually is not necessary, so it's just calling the function. Get rid of this. Alright, and you know what? Let's just run this and see what happens. So I need to bring in an image. So I have a Mona Lisa image. 1 second, I'll get it. So you guys just find any image online. So let's get the Mona Lisa. Let's see, this is a Mona Lisa, and so you're gonna save this and you're gonna store it in the same path as your project. Okay, so I'm gonna get it from my PC. Give me a second. Users. Okay, so I have it here. I'm gonna drag it. Can't even drag it. Okay. Okay, so I dragged it and now it's in here. Okay, this is the Mona Lisa. And now if I run this --file Mona Lisa.jpg, what it's going to do is it's going to take that argument, and then it's going to run the function convert image, and scale and output file, since they have this default value, that's going to be passed into the convert image function, and then it's going to store it into the output file. And we just define, since we didn't explicitly define a name for the output file, it's going to default to results.txt. And you know, coming back to this function, we're going to store the ASCII image art into this results.txt file. So if I didn't write anything wrong, this should all work. So let's just run it. Okay, and so this looks a bit weird, right? But let's actually open up our results.txt. Give me 1 second. Yep. So the Mona Lisa so as you guys, let me just show you guys over here what it looks like, because it doesn't look great. All right, and the reason for that is the image is way too big. All right, so this Mona Lisa.jpg, this was 3000 by something, and so what we end up getting is something that's so dense, and I can't really see this image well, and so that's why we need to scale this down even more than the default 0.43 that I have. So let's change the scale to something like 0.05. Okay, and now this looks a bit more like the Mona Lisa. So yeah, let's open it from here. God, how do I show you guys? Okay, I'm gonna find a better image. So this is the image Mona Lisa. Like we can't really see it well, right? Because there's not much of a contrast for the Mona Lisa. Like I guess there is, but yeah, it's not that great, the program I showed you guys. So I'm gonna get a better image. Give me 1 second. ASCII workshop. Yeah, we're gonna use this image. So this is a bit simpler, and you know, all these are the same colors, and so if you run this, file image.jpg, and now we look at our results.txt. Now this is a bit, it's a bit more obvious, right? So you can clearly see the outline of this figure. So if we compare those two, you can see that they're it's pretty much identical. And you guys might have noticed, like, the aspect ratio is a bit weird, right? And the reason for that is, you know, if we look at this, the height of a character is not the same as the width of a character. So a character is taller than it is wide. And so what ends up happening is, when you have so many characters, it becomes so elegant, it elongates itself vertically. So compared to the original image, the ASCII art is going to be much taller. And so we can try to fix that issue by really reducing the scale once again. So if we do something like dot scale 0.01, what should happen? Okay, this is a scale that's way too small. So let's see something like 0.1, I guess. As you can see, it doesn't, you know, it's not perfect, our program, right? Like, even when we reduce the scale, it still has this sort of a super weird aspect ratio, and also we can't really see this character well. Okay, so your guys' challenges is, one, to be able to find a way to actually resolve this issue. Like, how can we make this code that I showed you guys better? And one way to do that is explicitly define the you know, take into account this height of a character and the width of a character. So you can make the image that we see a bit more realistic. So I'll just revert back to the original one, since I think that one looks a bit better. You know, you can see the details, his eyes, this is like the nose, right? This is the hair. But the only thing that's bothering us is the fact that the characters are taller than it is wide. So let's try, my challenge for you guys is to find a way to maybe get rid of this weird aspect ratio that we're getting. Okay, and the second thing, which is what we've written for you guys, is to try to find a way to get this in RGB, right? Because we're losing the details here by only having it as white, and we can try to find a way to convert it into preserve the colors. We can't do that using a text file because all the text are just white. But we can do is use something like a turtle library, where we can have the text colored. And so essentially, you would just want to have the text match the color that you see in this image, but just use different letters to represent a pixel, and see what effect that has on what you came up with. It's going to be difficult for sure, but this is your challenge. Make sure you look at, you know, Turtle library, like the Turtle documentation, or maybe you can even use in the library in Python. So good luck for that, and I hope you guys enjoyed today's workshop.